Very good morning to all of you. Today we'll be speaking about the subject Automata languages and computation. And in this, our focus of discussion today will be Unit 1 of the subject Automata languages and computation. Unit 1 introduces automata concept, finite state automata, some central concepts of automata theory. So we'll be focusing on these introductory topics. Okay. Now coming to Unit 1, wherein we need to discuss the central concept of automata theory. Let us look at the first word, automata. So automata is a plural of automaton. And what is the meaning of automaton? The meaning of automaton is something done automatically. Now, coming to the languages. Your languages can be formal languages or your languages can be informal languages. To communicate with a computer, we need a language. Okay. So that language will be a computer language. And that computer language requires whatever the other natural languages require. Like any language, say English has what? English has letters, digits, numbers, punctuation marks, alphabets, sentences, words. So deriving from the natural language, a computer language will also require what? It will require ABCDs, it will require 1, 2, 3s, it will require all the components like sentences, words and paragraphs and all that in computer language also. So for a computer language, what is an alphabet? So for a computer language, an alphabet is a finite, non-empty set of symbols. Those symbols can be letters, those symbols can be digits, those symbols can be punctuation marks. And an alphabet is defined using this symbol called as sigma. So sigma is a set of A, B. So it's an alphabet. Sigma is a set of 0, B. It's an alphabet. Sigma is a set of I, J, K. Say for example, you have a language called as Algol language. We know that Algol language has 113 letters, then it has digits, operators, and go to and if, which are the sequential operators. Similarly, sigma is for what? Sigma is to define an alphabet. And what is an alphabet? It's just a non-empty set of symbols. And what those symbols can be? Those symbols can be letters, digits, punctuations, etc. See here, the sigma equal to 0, 1. What we are saying about it? It's a binary alphabet. Sigma equal to A to Z in lowercase. So what it is? It's an alphabet of lowercase letters. The next one is alphabet of uppercase letters. The next one is alphabet of digits. Similarly, just as a language has alphabet, similarly a language has string. So what then string can be? Its string is just a concatenation of finite symbols from the alphabets. We have an alphabet. What is the alphabet? This is our alphabet, sigma. And when I concatenate those symbols from the alphabet, they become strings. Okay. So the formal definition of a string is here. A string over an alphabet sigma is a finite sequence of symbols drawn from sigma. Let us say our alphabet is sigma equal to A, B. Then our string can be A or AB or AAABB, like that. You also have null string denoted by lambda. So when it is null string, so it contains no letters. So it means it's an empty string, okay, like an empty set. So it is denoted by what? Lambda. Now let us recollect. This symbol is for what? This symbol is for alphabet, okay, and this symbol is for what? This symbol is for string. W is for string. So this is my alphabet. Alphabet consists of what symbol? 0, 1. So when I concatenate this 0, 1, this 0 1 0 1 0 1 becomes a string. This 1 0 1 0 1 1 1 becomes a string. So we have just found out the length of those strings as 6 and 7. So as just mentioned, what is an empty string? Empty string is denoted by lambda. Okay. So and the length of the empty string is 0. The length of the empty string. So empty string multiplied by string equal to string multiplied by empty string, which equal to our string. Now let us say x and y are two strings. Now, and let us say x string consists of ABC and y string consists of DE. So when I say x into y, it will be ABCDE. So x into y is not equal to y into x. So as simple as that. So we understood what the first one is alphabet, the second one is a string. Now coming to the third one, words. What are words? Words are strings belonging to some language. So now what is my sigma? Sigma consists of x. And what is sigma here? Alphabet. Okay. So here, when I see this x, comma, xx, comma, xxx, all these are words of a language. Okay. So what is the meaning of a word? Let us repeat again. Word is strings belonging to some language. So we'll understand that with further examples, but we also need to understand what is valid alphabet, what is invalid alphabet. Okay. Now, here my alphabet consists of B, AB, BAB, D. Okay. So here AB is a letter. BAB also is a letter. They are not like three different letters. It's a single letter that we need to understand. Now, so whenever, let us say I tokenize this, say for this is my string, let us say I tokenize this string, it becomes what? Different ways, B, A, B, A, B, comma, B. Okay, or B, A, comma, B, B, A, B, comma, B. So let us look at this. We have B, then we have AB, then BAB. We have B, then we have AB, then we have BAB. So we need to look at this to validate them. So this, when this kind of string is scanned by the compiler, lexical analyzer, so it will be identifying the first symbol as a letter belonging to alphabet. Okay. So for the second letter, so it may identify, it may not identify, depending on its validity. Say for example here, this can be a valid example and this can be an invalid example. Why this can be an invalid example? Because we are seeing is that the first letter starts with B. When the first letter starts with B, or then the second should not also start with B. That's the condition. Coming to string length. Let us say this is my string. Okay, the length of the string is 5. As simple as that. Now this is my alphabet. B, comma, AB, comma, BAB, comma, D. And I formed a string of this alphabet as B, AB, BAB, B and D. And when I tokenize it, what it becomes? B, comma, AB, comma, BAB, comma, D, and it's valid, right? And what will be the length? 1, 2, 3, 4. The length of the string will be 4. So the reverse of a string is denoted by REV, or S to the power of R. So let us say my string is ABC. The reverse of string will be what? CVA. Similarly, let us say my string is this. The reverse of this string will be DBA, BA, BBAB, like that. Now, what is sigma? Sigma is an alphabet, and suppose we have some set of strings, okay, of a certain length in an alphabet. They can be denoted using the exponential notation. For example, sigma to the power of 0, set of all strings of length 0. Sigma to the power of 1, set of all strings of length 1. Sigma to the power of 2, set of all string of length 2. Sigma to the power of 3, set of all string of length 3, like that. Say for example, power of 2, all of them are 2, 2, 2, 2. Power of 3, all of them are 3, 3, 3, like that. Now, we have understood the importance of language. What is the importance of language? Language is a mode for communication. Natural language, we may have English, Hindi, Telugu, like that. Similarly, to speak to the computer also we require language. Okay. Now, how do I define a language to speak to the computer? Okay. And that language will be called as a computer language. Okay. Now, if it is a spoken language, it requires word. Okay. What a computer language requires, so that will be defined. So language, which is a computer language, can be defined in different ways. One way of defining the computer language is descriptive definition. The other way is recursive definition. The other way is regular expressions. And the other way is finite automata. So what is the importance of finite automaton then? It is used to define the language. Finite automata is used to define the language. What is the importance of regular expression? It is used to define the language. What is the importance of descriptive and recursive definition? It is used to define the language. So let us go for the first definition, descriptive definition. So descriptive definition is nothing, just some condition imposed on one some words. Okay. Say for example, we are saying that strings of odd length defined over sigma equal to a. So this is a comma a comma a. So all are of odd length. So here what we are saying, strings does not start with a, okay, but having sigma equal to what? A, B, C. So this is my string. No, none of them is starting with a, right? So here what is the condition we are imposing? Length 2, okay, and what is alphabet? 0 comma 1 comma 2. So here we are seeing that all of them are of length 2. Similarly, what is the condition imposed here? Ending with 0 and having what? 0 or 1. So all of them are ending with 0. Let us say we define a language called as equal. Okay, so here equal number of a's and equal number of b's over sigma equal to a comma b. You see here all of them are equal number of a's and b's. Now you have even language. Okay, so here also you see here all of them are even. Okay, so here we are just defining the integers. So you can see here some set of integers. Here we are defining even strings. So from this alphabet we are picking up, let us say 4, -2, 0, 2, 4. All of them are even. So here we are defining L equal to a to the power of n, b to the power of n. So you can see here all of them are a to the power of n, b to the power of n. So some condition imposed on the language. Similarly, let us say a to the power of n, b to the power of n, a to the power of n. You can see here the combination. Okay. Now similarly, let us say we are defining a factorial from this alphabet. So here we are defining a factorial from this alphabet. Factor of 1, factor of 2, factor of 3, factor of 4, like that. Okay. So let us say we have a square now and sigma equal to a. Then that square can be defined as like this. All of them are square example. Similarly, double square can be defined. So this also has few more example like prime numbers. You have this primes. Okay. With this short introduction, we have started discussing the subject automata languages and computation, and today we tried to define what is an automaton, what are the different central concepts of automata theory, what is a language, what is a string, what is a word, how to define the language using descriptive definition, all those. So thank you.